enthalpy, correct? H, which letter denote this H. So what do you mean by enthalpy? It is defined as the total heat content of the system. It is equal to the sum of internal energy and pressure volume work. H is equal to U plus PV. U is the internal energy, H is the enthalpy. So absolute enthalpy of a system cannot be determined. H is a state function. H is a state function. So enthalpy change. Enthalpy change is a delta H. It is defined as the heat exchanged with the surroundings at constant pressure. That is when the process is carried out in open container. Then delta H enthalpy will change. That means internal heat energy will differ. So when enthalpy change, it may be a exothermic or endothermic. So most of the chemical reactions are accompanied by energy changes. Some absorb energy while some releases energy. Exothermic reaction means when the heat is evolved. Endothermic reaction, if the heat is absorbed, then we say that it is exothermic and endothermic. So in endothermic, it releases energy. So therefore, the product contains less energy with respect to the reactants. The energy released as heat, so the surroundings warm. Endothermic reaction, it is reactions, the absorb energy, therefore the products contain more energy with respect to the reactants. So the energy is absorbed as heat energy, so the surroundings cool down. Example of exothermic reaction, all the combustion reaction. Endothermic reaction, all the dissociation reaction or decomposition reactions are example of endothermic reaction. So when you see the energy level diagram, relative energies of the product and reactants, the higher its energy, the higher its position. Energy level diagram shows that which is there in higher level. This energy level diagram for exothermic reaction. Look at this, products are there, reactants are there. So products have less energy than the reactants. In endothermic reactions, products have more energy than reactants. So the above arrow mark endothermic, the down arrow mark exothermic. So examples of exothermic reactions is given: neutralization, combustion, dissolving anhydrous salt, and reaction between acid and metal carbonate. Examples of endothermic reaction: atomization, photosynthesis, dissolving crystalline salt, and thermal decomposition are the example of endothermic reactions. So their enthalpies are there. In enthalpy, different type of enthalpies are there. Actually, whenever any reactions occur, there will be change in some process. So during that time, that heat also changes. That means enthalpy also changed. The standard condition to make comparison of the enthalpy changes, a fair comparison must be used. These are called as standard condition. At standard temperature and pressure, enthalpies are observed. That is known as standard enthalpy changes. Pressure of 100 kilopascal, temperature at 25 degrees Celsius. So every substance involved must be in its normal physical state at 100 kilopascal and 298 Kelvin. For example, water is in liquid. So when water is in liquid, that is comes under standard enthalpy. It can be represented delta H naught. We'll name it as standard enthalpy delta H naught. Example is given: CH4O2 gives CO2 plus H2O. So what is the standard enthalpy of combustion of methane minus 890.3 kilojoule per mole. You know that exothermic will be denoted by the negative sign, endothermic will be denoted by the positive sign. Here are various type of enthalpy changes are there. What are the types of enthalpy changes? Standard enthalpy change of reaction, for formation, for combustion, for neutralization, and for atomization, and for solution and hydration. So one first letter of that particular terms will be used near H for mention that. For example, standard enthalpy of reaction means delta HR. Formation means delta HF. For solution means delta H SOL. For hydration means delta H HYD. So this is the way we have to mention the enthalpy changes. So when we are calculating the particular enthalpy changes, which enthalpy change we want, we have to derive that enthalpy equation, then we have to calculate all those one. All the enthalpies are already observed by the scientists and given. The values are already given. First one, the standard enthalpy change of reaction. So what do you mean by heat of reaction, enthalpy of reaction? It may be defined as the amount of heat evolved or absorbed. That is, enthalpy change when the quantities of reactants have reacted completely as indicated by balanced chemical equation. Total, the reactants have reacted completely. Then it is known as heat of reaction. Example is given. So one example, and try to understand what type of enthalpy it belongs. Next, change of formation. Standard enthalpy change of formation. Standard enthalpy change of formation or heat of formation. So it is defined as the amount of heat evolved or absorbed when 1 mole of the compound is formed from its constituent element. In the standard state, it is known as heat of formation or enthalpies of formation. For example, ammonia is formed from nitrogen and hydrogen. So, N2 plus H2 gives NH3. So, here delta FH, that is enthalpy change of formation, is minus 46 kilojoule. And another one example is given, Fe plus O2 gives Fe2O3 and enthalpy change is given. It can be exothermic or endothermic. Any reaction, it may be exothermic or endothermic. Next one, standard enthalpy change of combustion. Combustion means it is a heating or react with oxygen. It may be defined as the amount of heat evolved when 1 mole of substance is completely oxidized or burnt in excess of oxygen. That is known as heat of combustion. Here the given example is combustion of methane is given. The heat of combustion is always negative. Because it is exothermic. Next, standard enthalpy change of neutralization. We know that heat of neutralization. It is defined as heat evolved when 1 mole of hydrogen of an hydrogen ion of an acid is neutralized completely by 1 mole of OH minus of a base in very dilute solution. So neutralization reaction is delta HN. This is neutralization reaction when hydrogen is combined with OH. So it dissociates into Na, dissociates into Na and OH. HCl dissociates into H and Cl. So H plus and OH combine to form water. So heat of neutralization of strong acid and strong base will remain constant and is equal to 57.1 kilojoule per mole because they are completely ionized in aqueous solution. In case of weak acid or weak base, heat out neutralization is less than 57.1 kilojoule per mole because some energy is used in dissociation or ionization of weak acid or weak base. Here the example is given HCl plus NaOH. You can note down this point. How does this enthalpy change for weak acid and weak base? The example also given. Note down the example. The standard enthalpy change of neutralization reaction is always exothermic because it is exothermic reaction. So value will be in negative. Atomization. What do you mean by atomization? When a substance is there, what happened to the substance? A substance will react and dissociates into, if it is a single compound, it dissociates into elements. If elements are there, means it combine and to form a compound. Correct? So some of the elements are monoatomic state. So solid metal exists at in which bonds between the atoms are metallic bond in the solid state of metal. Non-metal like carbon and boron also have JN molecular structure. So most of the other solid non-metals are polymeric. So the liquid and gaseous non-metals are diatomic. So most of the liquid and gaseous non-metals are diatomic. So atomization is the formation of free atoms from the standard state of elements. Atomization is the formation of free atom. So one in standard state, elements will be present in either gaseous or liquid or solid. From that, atoms are formed. That is known as atomization. If an assembly of free atoms, there is no force acting between the atoms. So atomic state is gaseous. In gaseous means there is no force of attraction between those bonds. So if the atoms will be in the solid state or liquid state, it will be converted into gaseous state, then we say that it is atomization. Involves a change from solid to gas. So atomization enthalpy is approximately equal to enthalpy of sublimation. So phase transformation enthalpy also there. Fusion, enthalpy of fusion, enthalpy of sublimation. What do you mean by enthalpy of fusion? Conversion of heat absorbed when 1 mole of solid changes into liquid. That means melting point. What do you mean by enthalpy of sublimation? Defined as the heat absorbed when 1 mole of solid changes into vapors completely. That is heat of sublimation or enthalpy of sublimation. What do you mean by enthalpy of vaporization? Heat absorbed when 1 mole of liquid changes into vapors completely at its boiling point. That is known as vaporization. So this fusion, vaporization, sublimation comes under phase transformation. So when you see this standard enthalpy of atomization, the enthalpy changes when 1 mole of gaseous atom is formed from its element as standard condition. So hydrogen is there, diatomic atom. So one hydrogen is formed from gaseous atom. Then it is known as atomization. In such a way, sodium is present in solid state. If one gaseous atom is dissociated from the solid, then it is known as atomization of sodium. Standard enthalpy of atomization of the noble gas is 0. Standard enthalpy change of atomization is noble gas is 0 because all of them exist in monoatomic gases. Because it is present itself is a gaseous state. if monatomic gases are present in the gaseous state, so that its standard enthalpy change of atomization will be 0. But monatomic element will be present in elemental state, either in the solid state, then it will be converted into gaseous state, then we will have enthalpy change of atomization. Standard enthalpy change of atomization is always endothermic because it absorbs energy, endothermic. So that enthalpy change will be denoted by positive. Solution. Standard enthalpy change of solution. Standard enthalpy change of solution in such a case, when we are preparing the solution, either it may be heat is evolved or heat is absorbed, then we can say this is the standard enthalpy of solution or dilution. Heat is either evolved or absorbed when a solute dissolved in a solvent. So the amount of heat evolved or absorbed changes with change in concentration. Then it is known as enthalpy of solution. For example, hydrochloric acid. We are dissolving hydrochloric acid with 5 molecules of water. Then enthalpy change of dilution is minus 64.06 kilojoule. At the same time, HCl is dissolved in 50 molecule of water, then enthalpy is minus 72. And that hydrochloric acid dissolved in 200 molecule of water, then the enthalpy is minus 73. So it changes. So where HCl stands for 1 mole, the enthalpy change indicated in each equation is called integral heat of equation. It depends on the concentration of the solution. So the change in enthalpy per mole of solute associated with the dilution of solution from one concentration to another is called the integral heat of dilution or enthalpy of dilution. Hydrochloric acid gas is there. If it is dissolved in water, we will get hydrochloric solution. During that time, minus 74.8 kilojoule heat is evolved. So that is the enthalpy change of dilution. Sodium chloride aqueous is there. Sodium chloride solid, when we are dissolving in water, it changes into liquid. During that time, 6.0 kilojoule mole heat is evolved. So this is the way we can mention the standard enthalpy change of dilution. An infinitely dilute solution is one which does not produce any further enthalpy change when more solvent is added. So when more solvent is added, what happens? Enthalpy will not change. The standard enthalpy of a solution may be exothermic or endothermic. Some of the reactions are exothermic, some of the reactions are endothermic. For example, dissolution of acid and base is exothermic. At the same time, a salt, ammonium chloride, is endothermic. Standard enthalpy for measure of hydration. Hydration means when enthalpy change, 1 mole of hydrated salt is formed from 1 mole of anhydrous salt under standard condition. Hydrated salt means a salt which contains water molecule is known as hydrated salt. So hydrated salt is formed from its anhydrous salt. How do anhydrous salt change to hydrated salt? By adding water. Then it is known as standard enthalpy change of hydration of an anhydrous salt. Here example is given: sodium thiosulfate H2O gives sodium thiosulfate 5H2O. We can write the example: Na2CO3 plus 10H2O gives Na2CO3 10H2O. That also example of standard enthalpy change of hydration. Apart from this enthalpy change, another important thing, ionization. Ionization means that change into anion and change into cation. During that time also enthalpy changes will be there. So electron gain in enthalpy and ionization enthalpy. So electron gain enthalpy occur when 1 mole of an atom is converted to its anion. So when it gain electron, then it is known as electron gain enthalpy. Ionization enthalpy. Ionization enthalpy, if an atom, in an atom one electron is added, it changes to cation. Then it is known as ionization enthalpy. Enthalpy of bond dissociation also there. What do you mean by bond dissociation? Amount of energy required to break a chemical bond or in a gaseous molecule is called bond dissociation energy. So all those enthalpy example, everything is given in your textbook. Read your textbook, read all that enthalpies and try to understand that. And it will be useful for you to apply in the problems.